Greetings for everyone. We hope that everyone is doing well. Today we are going to perform our problem solving about question number 4 involving conic section hyperbola.
This is the question given to our group. Two control towers are located at points negative 500 at Q coordinate and positive 500 at R coordinate. On a straight shore where the x-axis runs through, all distance are in meters. At the same moment, both towers sent a radio signal to a ship out at sea, each traveling at 300 meters or microseconds. The ship received the signal from Q 3 microseconds before the message from R. A. Find the equation of the curve containing the possible location of the ship.
So, from the given, we try to illustrate it as our reference to answer the question. Our group form a graph. Here, we have the coordinate Q. And since the negative 500 is a huge number to be seen in the graph for us, we try on simplify the illustration to understand and answer the question better. We change the negative 500 and just use or replace it to negative 50 and coordinate R 50 as well. You can also see from the graph that the point Q is near the ship. Since point Q was received the signal 3 microseconds before the message from R.
Let the origin be the center of the hyperbola. Using the given speed of the radio signal, 300 meter per microsecond, and knowing that there are time delayed between the two radio signal of the tower is 3 microseconds. This implies that the radio signal traveled 300 times 3 equals 900 meters. Here we multiply the speed of radio signal and the time delayed, giving us 900 meters. Meaning, the difference between the distance of the ship to R and the ship to Q is 900 meters if we subtract the distance between the two. And we denote it as equal to 2A. Now, we have C here as 500 because it is the distance between the focus up to the center. And we know that C stands for the distance between the center and a focus. So as we can see here, we have 2A equals 900, then A equals 450,
and A squared is equal to 202,500.
To find A, we just divide both sides by 2 to let A be the variables we're finding. So, 900 divided by 2 is equal to 450. And now, to find A squared, we just square 450, which is the value of A, giving us 202,500.
Since we now have the value of A, we can already plot the coordinates of vertices which are negative 450, and 450 to our graph.
Now, to find the B squared, we manipulate the formula of C squared equals A squared plus B squared. Transforming it, we have B squared equals C squared minus A squared. We transform it since we're finding the value of B. Then we substitute the given that we have. C is equals to 500 and A equals to 450. Now we have B squared equals 500 square minus 450 square.
Substituting that to our previous formula, we will have B squared is equal to 250,000 minus 202,500. Solving that equation will give us 47,500 as B squared. Since the signal from Q was received first, The ship is closer to Q than R. So, the ship is to the left branch of this hyperbola. By substituting the values we got earlier, we will then arrive to our equation, which is x squared over 202,500 minus y squared over 47,500 equals 1.
For the bonus question, find the coordination of the ship if it's 200 meters from the shore.
Using y equals 200, we then solve x squared over 202,500 minus 200 squared over 47,500 equals 1. Simplifying 200 squared will then get us 40,000. After that, reducing negative 40,000 over 47,500 into its lowest term will give us negative 16 over 19. So by the addition property of equality, I add both sides by 16 over 19, which then will give us this. I move negative 16 over 19 to the right, so it became positive 16 over 19. So 1 plus 16 over 19, that will be 35 over 19. And then for us to eliminate the denominator of x squared, we just need to multiply both sides of the equation by 202,500. So 202,500 in other words will be multiplied to 35, and that will be 7,087,500. And simplifying 7,087,500 over 19 will be 373,026.31. Now x squared is 373,026.31. For us to get the value of x, we need to square both sides. So, the value of x less than 0, left branch, rounding off to 2 decimal places will be negative 610.76. Hence, the coordinates rounded off to 2 decimal places of the ship if it is 200 meters from the shore, y equals 200 will be negative 610.76, 200. So, since we have the coordinates negative 610.76, 200, we can now plot it in the graph for us to illustrate.
That's all for our presentation regarding solving problems involving conic sections, specifically the problem number 4, which is a hyperbola. Thank you, and we hope you have listened very well. Adios!